Let's see, method about isocline. Um, this is a method mm, to draw the direction field. Okay. So let's see differential equation dy dt is f of t comma y. Um, so we're talking about this one. This is autonomous if f of t comma y. This is a function on the right-hand side. Okay. Does not depend on the independent variable t. Okay. So here t is a independent variable. I'm sorry. So t is independent variable, y is dependent variable. So f is depends on only y, independent variable. Okay, then we say that the differential equation autonomous. Okay. Yeah. But it means that what? If t, in that case that, differential equation is autonomous, then when you draw the direction field, then we're gonna get the slope of the solution um, along the horizontal line. What that means, you see, for example, right here. So one of the example of autonomous was this dv dt equals 2 minus v, right? So look at the right-hand side. This is f of v, right? This is f of v. So this is one example of autonomous. And then we did draw the direction field of this differential equation. It turns out that this. Now, as you can see that it's drawing the horizontal line. Then what every single the slope of the v, which means the dv dt, is identical, right? Is 1, 1, 1, 1, 1, something like that, right? Because the f of this function, independent to I mean does not depend on t. Okay. So the every single, I mean, so autonomous, if differential equation is autonomous, then when you draw direction field, then just drawing, when you draw the horizontal line, then the value of dv dt, which means that the slope of the solutions is identical at every single point on that horizontal line. So now okay, so let's move on to the method of isocline. So isocline. So find the core isocline. So what does that mean? Isocline. Isocline is the core or just straight line, which dy dt is constant. Okay, isocline. So this is the special case. I mean, that's also that horizontal line is also isocline. So especially in autonomous, the isocline must be horizontal line. Okay. Okay. So it's the example. Let's see. Okay. So here's the example. dv dt equals v plus t. All right. So is this is not autonomous. Okay. This is just regular differential equation. Okay. Let's find out the isocline. That means v plus t must be we got to find out um fix the v and t somehow, or figure out the relationship between v and t so that this one turns out to be constant. Okay, so settings this one v plus t equals c is a constant. Okay, then we plug in specific value into c. Okay, for example 0, 1, 2, 3. Okay, 4, 5, 6. So we can figure out the relationship between v and t. So now we can figure out isocline. So for example, when c equals 0, let's see, when c equals 0, then v plus t equals 0, right? That means if v is negative t. So we can draw the graph of, I mean, actually the straight line, right? So just drawing the straight line of this linear equation, which is v is negative t, so maybe, oh no, maybe this one, I think, yeah, probably. Yeah, I'm sure that. So v is negative t. So now we draw the just that line. Okay. So that's the isocline. Let's see if this is really isocline, which means that, dB/dt is really constant along that line. So V is a negative D, then just plug in just numbers into V, 0, 1, 2, 3, 4, 5, then T will be determined, right? And then we can figure out dB/dt, right? So since V plus T equals 0, actually, so dB/dt is 0. So all along that line, every single point, the dB/dt must be 0, which means the slope is 0. So we're gonna get the horizontal line segment for each point. I mean, so yeah, the other, cases, C equals 1, 2, 3, 4, 5, then you can figure out the dB/dt, which is slope of V, okay, slope of V at along the line. So these are isocline. So why we need to figure out the isocline? Because uh from there, you can see, then by figuring out the isocline, it's easy to figure out the integral chord. Okay, so going back to this example, what's the integral chord? Integral chord is the graph of the unexact solution. Okay, so depending on initial condition, we're gonna have many exact solutions, right? So this is one of the exact solutions, a graph of exact solution that is called the integral chord. Then by figuring out the isocline, we can easily plot the graph of integral chord. So now from here, there was the integral chord right there. You just connect the line segment crossing the isocline. You see? And then let's see here and this one. Like this. Okay. You see that here? Um, just graph is just like all the integral chord approach that line, right? This one. Okay. So that line, right? Oh, okay. So so we can see that, oh, okay, so solution just approach that line. Or you can say as t approaches infinity, the graph, isocline goes upward or below down, goes infinity or negative infinity. It's kind of diverse, right? Okay, that's the example of the method of isocline.